students. Now you are going to learn in the topic capacitance of various geometries using Laplace equation. You are going to learn how to calculate the capacitance of a coaxial capacitor. So this is a coaxial capacitor. You can see there are two rings, and the inner ring, inner circle with radius A, and outer circle with radius B, and the length of the coaxial cylinder is L. Okay, so the area of this coaxial capacitor will be 2 pi A into L. I'll tell you how you have arrived at that. And in this inner radii, the potential V will be equal to V naught, and in the outer radii, the potential V is equal to 0. Now, we'll write the equation del square V in Cartesian coordinate system 1 by rho into dou by dou rho, rho into dou V by dou rho plus 1 by rho square, dou square V by dou phi square plus dou square V by dou Z square equal to 0. This is your Laplace equation in cylindrical coordinate system. And when you see, we have considered only the radius in account. The variation of radius has been taken into account. So there is no variation along phi and Z. There is no variation. So the above equation reduces as del square V is equal to 1 by rho dou by dou rho into rho into dou V by dou rho, which is equal to 0. Now rho into 0 is 0. So I am integrating once. When I integrate once, what will I get? What will I get? Rho into dou V by dou rho equal to A. Now I am going to take this rho to the denominator. So my equation will be dou V by dou rho is equal to A by rho. And again when I integrate 1 by x, it is log of x. Here we will write it as ln, natural logarithm. A into ln of rho plus b is the constant of integration. B is constant of integration, and we have arrived at the general equation. Now we have to apply the boundary condition. When the radius rho equal to A, V is equal to V naught. Apply this in the above equation. Or let me write the second equation also. Rho equal to B, V equal to 0. So this is the first boundary condition, second boundary condition. So I am applying the second boundary conditions in this main equation. Okay. When I apply the second boundary condition, 0 is equal to A ln of B plus capital. So what is capital B from here? Minus A ln of B. This is your value of B. Okay, by substituting the second equation. Now I am going to substitute. First equation. This equation in the main equation. So when I substitute, B will be equal to V naught is equal to A ln of A. And what is B? Minus A ln of B. So substitute minus A ln of B. So when I substitute like this, I will get this equation, and A is common. So V naught is equal to A into ln of A minus B. I can write as A by B. So what is A? V naught divided by ln of A by B. This is my A to V naught ln of A by B. Now substitute this A value in here. I will get the B value. So what is B value? B value is equal to minus V naught ln is natural logarithm A by B into ln of B. So this is my B value. I have got the A value and I have got the B value. Now substitute this B value and this A value in the equation, in this equation 1. So when you substitute, V will be equal to V naught ln of A by B minus into ln rho into ln of rho minus V naught ln of A by B ln B. So I have substitute. Okay. So when you see this equation, these two are common terms. So I can write V is equal to V naught ln of A by B into ln of rho minus ln of B. Okay. You got it? So V is equal to V naught ln of A by B into ln of rho by. So this is my equation for potential. Hope you have understood this. Shall we go to the next part, how to calculate the capacitance? So shall I rub this off? Okay. Now I'm going to calculate capacitance in 3 steps. I will first calculate the electric field intensity, then calculate electric flux density, then I will go for Gauss law. So shall we start? Yeah. So what is electric field intensity? How it is related? How electric field intensity is related? E is equal to, first I'm going to calculate E. Calculate E. What is E? E is equal to minus del V, which I can write as minus dou V by dou rho into A rho. So now minus dou by dou rho. What is V? V naught ln of rho by B divided by ln of A by B into A rho vector. Okay, so I will calculate E as E is equal to, minus will be there. I'm going to differentiate with respect to rho. When I differentiate, V naught is common, so I'll take it out. Here there is rho and here this log. So V naught by ln of A by B is a constant, so I'm taking it out. And ln of rho by B is, what is log of x? Differentiation of log of x, 1 by x. So 1 by rho by B into, what is differentiation of rho? It is 1 by B into A rho vector. So E is equal to minus V naught ln of A by B into B and B will get cancelled. You will have into 1 by rho A rho vector, or I can write it as E is equal to, I'm taking this minus here. Okay, when you will have minus, see I'll show you. I'm going to write as V naught by rho into ln of A by B inverse. Why? Because if the minus in the denominator and the numerator doesn't make a difference. So if I take this minus to the denominator, it will become inverse. So I can write this as V naught by rho into ln of B by A. This is my electric field intensity vector. Okay. So what is the second thing I have to calculate? I have to calculate D. Calculate D. How you will calculate D? D is equal to epsilon into E. So D will be equal to epsilon into V naught rho into ln of B by A rho vector. So I have calculated D also. Okay. So which I can write it as rho S. D is also equal to rho S. Okay. Now I want to calculate Q. Q is equal to rho S into ds. What is rho S? Rho S is epsilon V naught by rho into ln of B by A into ds. All these are constant value, so I'm taking it out. Epsilon V naught by rho into ln of V by A. So integration of ds. Integration of ds will give me S. Into S. S is your surface area. So in this surface area, I am going to substitute 2 pi A into L. 2 pi A into L. So Q epsilon V naught by rho into ln of V by A into 2 pi A into L. When you will have V naught value, when rho is equal to A, when your radius is equal to A, you will have your V naught value. So I'm going to rub this off. I'm going to rub this off here. So here I'm going to write Q is equal to epsilon V naught by, instead of this rho, I'm going to substitute A into ln of V by A into 2 pi A into L. So this will be equal to 2 pi epsilon V naught L by ln of V by A. What is capacitance? What is capacitance? C is equal to Q by V naught. So bring this V naught to the denominator. What is remaining? 2 pi epsilon L by ln of V by A farad. So this is your capacitance due to a coaxial capacitor. Hope you understood. Thank you.